Hello students, today we will discuss about cannizzarO reaction. CannizzarO reaction is characteristic reactions of aldehydes only. In cannizzarO reaction, aldehydes undergoes change in presence of alkali, and under chemical change aldehyde gives alkali salt of carboxylic along with alcohol. So two products are obtained, that are alkali salt of carboxylic and alcohol. So what is cannizzarO reaction? CannizzarO reaction is given by aldehydes only, and among aldehydes only those that have zero alpha hydrogen. What it means? Those aldehydes that doesn't have alpha hydrogen undergoes chemical change with alkali and gives alkali salt of carboxylic and alcohol. So cannizzarO reaction is represented by those aldehydes that contains zero alpha hydrogen or no alpha hydrogen reacts with strong alkali like NaOH, KOH and gives alkali salt of carboxylic and alcohol. For example, HCHO, no alpha hydrogen, reacts with NaOH, concentrate, formation of HCOONA, sodium salt, alkali salt of carboxylic with CH3OH, alcohol, methanol, 2 carbon, 2 ACHO. This is sodium salt of carboxylic and this is methanol. Alcohol and carboxylic are obtained. Next, like C6H5CHO, benzaldehyde without alpha. Phenyl group has no alpha hydrogen because all the carbon hydrogen are same and it's cyclic in nature. Now reacts with NaOH. NaOH, same condition, concentrate 2C6H5CHO, formation of C6H5COONA, sodium benzoate, alkali salt of carboxylic with C6H5CH2OH, benzyl alcohol is formed. Benzyl alcohol is formed. So under cannizzarO reaction, those aldehydes that have not alpha hydrogen undergoes chemical change, reacts with strong alkali like NaOH and results alkali salt of carboxylic with alcohol. So next condition for cannizzarO, if there is no alpha hydrogen, so if CCl3CHO simply called chloral, this chloral will undergo cannizzarO reaction. Yes, because it has absence of alpha hydrogen, so react with NaOH concentrate and two molecules of this converts into CCl3 COONA with CCl3 CH2OH. Alkali salt of carboxylic along with alcohol is obtained. Take the next example for cannizzarO. If we have CH3 whole thrice CCHO, it has any alpha? This carbon is alpha carbon without any alpha hydrogen. Yes, it will undergo cannizzarO reaction, reacts with NaOH, concentrate two molecules of aldehyde, formation of CH3 whole thrice C COONA, alkali salt of carboxylic with CH3 whole thrice C CH2OH, alcohol is formed. So whenever those aldehydes that have zero alpha hydrogen reacts with concentrate NaOH, they give alkali salt of carboxylic with alcohol, and this reaction is termed as cannizzarO reaction. Next, in cannizzarO reaction, since we know that, taking very simple example, SCHO reacts with NaOH, we have discussed already, give the product HCOONA with CH3OH. This is the product formed, two molecules of SCHO. So on the basis of oxidation number के बेस पर cannizzarO किस कैटेगरी को बिलोंग करती है, रिडॉक्स की. Let's see here. Whenever there is addition of oxygen, then reaction is called oxidation reaction. When there is addition of hydrogen, then reaction is termed as reduction. On the basis of oxygen and hydrogen, the definition of oxidation and reduction is what? When there is addition of oxygen, oxidation is carried out. When there is addition of hydrogen, reduction is carried out. Since here methanol formaldehyde takes oxygen and get oxidized, same formaldehyde takes hydrogen and get reduced, gives alcohol. So oxidation and reduction of same molecule is carried out. So it's a type of disproportionation redox reaction. Disproportionation redox reaction. What it means? When there is oxidation and reduction of the same molecule in a chemical chain, it's a category of disproportionation redox reaction. So cannizzarO reaction on the basis of oxidation number belongs to disproportionation category of redox reaction. If we take on the basis of number of electron transfer, that is oxidation number, then here the oxidation number of carbon will be 2 hydrogen plus 1 carbon plus 1 oxygen equal to 0. Now 2 into 1 in normal state hydrogen we have plus 1 x. Now plus oxygen in normal state we have minus 2. Class 11th में discuss कर चुके हैं. 2 plus x minus 2 equal to 0. Therefore x equal to 0 here. Oxidation state in HCHO is 0. 0 for what? Carbon. Carbon has 0 oxidation state. Now here oxidation state of carbon, HCOO minus Na plus. So in here carbon 1 plus X plus 2 oxygen in normal state equal to minus 1. 1 plus x plus 2 minus 2 equal to minus 1. Now 1 plus x minus 4 equal to minus 1. X minus 3 equal to minus 1. X equal to plus 2. Here carbon has plus 2 oxidation state. 2 plus. Now here in alcohol, X plus 3 hydrogen plus oxygen plus 1 hydrogen. Therefore X plus 3 into 1 plus minus 2 plus 1. Therefore x plus 3 minus 2 plus 1 equal to 0 equal to 0 equal to 0. Now x plus 1 plus 1 equal to 0. Therefore x equal to minus 2. Here carbon has minus 2 oxidation state. Minus 2 oxidation state. So carbon oxidation number in reactant is 0. While in product it has two different oxidation state. In first one, alkali salt of carboxylic, it get oxidized. While in second, in alcohols, it get reduced. So oxidation and reduction of the same element is carried out in a chemical change. That's why it belongs to disproportionation type of redox reaction. So in cannizzarO is an example of disproportionation redox reaction. Next, how cannizzarO happens, the mechanism of cannizzarO. Let's see mechanism of cannizzarO reaction. Mechanism. In first step, one aldehyde molecule under attack with OH minus, a nucleophile attacks on one aldehyde molecule. It's a fast reaction. Here, this movement of pi electron to more electronegative oxygen, so negative charge appears at oxygen and positive at this carbon. So at this positive charge, OH minus get attached like this. COH single bond H single bond O negative. In next step, again OH minus attack. So this OH minus attacks. Here heterolysis takes place, heterolysis, due to which this electron is taken by this oxygen, H plus released from here. This released H plus eliminates in the form of water. Now the structure formed become H, single bond C, single bond O negative, single bond O negative, single bond H. This structure is formed. Now in second step, this formed structure that has two oxygen with negative charge reacts with next aldehyde molecules, because in cannizzarO two aldehyde molecule reacts. Here again this movement of pi electron to more electronegative oxygen, so positive charge appears to this carbon, due to which this carbon hydrogen bond get break, and here electron are accepted. This electron moves in the form of pi bond, due to which it becomes in balance condition. Now breaking of this bond takes place, electrons are taken by hydrogen, and this hydride comes and attached to this carbon. This H minus comes here, that's why it's called hydride shift. It's called hydride shift, due to which it becomes negative. Here negative oxygen, it becomes CH3 single bond O negative, and it becomes HCOO minus. So HCOO minus with CH3O minus. This CH3O minus under hydrolysis reacts with the water released. Here H plus OH minus H plus reacts with this negative charge unit and forms methanol. So alkali salt of carboxylic and alcohol are the final product in cannizzarO mechanism. I repeat the mechanism steps. In first step, aldehyde molecule shows the shifting of pi electron towards more electronegative oxygen, due to which oxygen becomes a negative charge and carbon has positive charge. Here due to OH minus attack, it comes and attached to the positive charge carbon, and this structure is formed. Now here next attack of OH minus takes place, and here breaking of heterolysis. Heterolysis, breaking of this bond takes place, OH bond, and both the shared electron are received by one oxygen and it becomes negative charge. H plus released reacts with OH minus and form H2O. Now in second step, this two oxygen containing negative unit reacts with another aldehyde molecule. Here hydride shift takes place from one aldehyde to another, and this hydride shift results alcohol formation. So here hydride is released by one and accepted by another aldehyde. that results alkali salt of carboxylic and alcohol as the final product. Next, in cannizzarO, if two unidentical aldehydes are taken, if different aldehydes are taken, different aldehydes like C6H5CHO, this is called benzaldehyde, reacts with next aldehyde, formaldehyde. Both have absence of alpha hydrogen, reacts with NaOH concentrate. So in cannizzarO reaction, what the product will be formed? So big aldehyde undergoes reduction while the small aldehyde undergoes oxidation. जो स्मॉल एल्डिहाइड होगा उसका ऑक्सीडेशन होगा और जो बिग एल्डिहाइड होगा जिसका बल्कि एल्किल या फेनिल या एरिल या उसका मॉलिक्यूलर वेट ज्यादा होगा उसका रिडक्शन होगा. सो व्हाट विल बी द फाइनल प्रोडक्ट? C6H5CH2OH. It will be reduced to alcohol and it will form HCOONA. This is the trick. When two different aldehydes comes together under cannizzarO reaction, so after chemical change, the big one get reduced from alcohol and the small one get oxidized to give alkali salt of carboxylic. So benzyl alcohol and sodium formate is formed. Taking next, like CH3 whole thrice C CHO with SCHO reacts with NaOH concentrate. So formation of CH3 whole thrice C CH2OH. The big one get reduced while smaller get oxidized. This is the trick how the final products are obtained when two different aldehydes with no alpha hydrogen undergoes cannizzarO change. So next thing, if identical aldehydes undergoes cannizzarO, so it's simply called cannizzarO reaction. cannizzarO reaction with NaOH. And whenever different aldehydes undergoes cannizzarO change, reacts with NaOH concentrate, it's called cross cannizzarO reaction. So what is the difference between cannizzarO and cross cannizzarO reaction? In cannizzarO reaction, identical types of aldehyde with zero alpha hydrogen participates, while in cross cannizzarO reaction, unidentical, that is different types of aldehyde with zero alpha hydrogen participate in the reaction and give the product, so called cross cannizzarO. In both the cases, the reaction takes place with same type or different molecules of the compounds, but whenever, so it's called intermolecular cannizzarO reaction. cannizzarO intermolecular means what? Among molecules means identical, same type, or unidentical. Whenever cannizzarO or cross cannizzarO is carried out, it is among the molecules of identical or unidentical types. But when the cannizzarO takes place within molecule, no additional molecule is required. Certain molecules like this, it contains zero alpha hydrogen, and it has two aldehyde groups. No next or additional aldehyde is required. Within a molecule, it undergoes cannizzarO chain, then it's called intramolecular cannizzarO reaction. It's important for competitive aspirants. Intramolecular, अभी तक हमने जो डिस्कस किया है वो intermolecular cannizzarO था, whether it was cannizzarO simply or cross cannizzarO reaction. In both the cases, identical or unidentical molecules were taken, that is among molecules. And in intramolecular cannizzarO, within molecule, the molecule itself contains two CHO groups and has 0 alpha hydrogen. Now here CHO, single bond CHO reacts with NaOH concentrate. So one will get reduced and another will get oxidized. So if this one undergoes with dilute HCl, formation of CH2OH, COOH. This is called glycolic acid. So here the two aldehydes with 0 alpha hydrogen are present within a molecule, so undergoes cannizzarO change. It's called intramolecular cannizzarO. And what is cannizzarO and cross cannizzarO? It undergoes intermolecular when two identical or unidentical molecules comes and reacts with concentrate NaOH. So students, this is all about for cannizzarO reaction. Thank you everybody.